In this video, we're going to find the midpoint and the length of a line. We're going to look at some graphs, and you have done some work on finding the equations of graphs and looking at the gradient and the y-intercept. So if you have a look at this graph, then just pause for 1 minute and think about what you think the equation of this line is. So in order to find the gradient, you need to consider how many you go up when you go along one. So for every one that you go along your x-axis, how many do you increase up your y-axis? So we're going to take a point here and go along one, and we're going to see how many we go up, and you can then verify what your gradient is. And you can see here that going along 1 on our x-axis, we have gone up 2. We've gone up, so it's a positive gradient. So the gradient of this line is 2, and the y-intercept is here. So the y-intercept is at the point 3. So the equation of the line is y equals 2x plus 3. Now, any point that sits on that line is going to follow this rule. This is the rule that gives you your relationship between your x and your y coordinates. So if we take the point at A, we can see that the x-coordinate is going to be -1 because it is sitting on x is -1. And if we put that into our rule of our line, y equals 2x, which is 2 times our -1 plus 3. 2 times -1 is -2. Add on 3, and we get 1. And therefore, the coordinates of the point at A are -1, which was our x-coordinate, and our y-coordinate of 1. And you can see that that is indeed the coordinates at A. At B, we have that x equals 1. So you can see that at the point B, we have got the x-coordinate of 1. And we know that our rule is 2 times our x-coordinate of 1 plus 3. That's 2 plus 3, which is 5. So we know that the coordinates at B are 1, 5. There are lots of other points on the line, and all of those points will also follow the rule of the line. So, for example, if we have a point down here, we know that our x-coordinate is -2, and if we follow our rule of doubling our x-coordinate, 2 times -2 is -4, add on 3 is -1, and that is indeed the coordinates of that point. So any point that sits on that line follows that rule. So we're now going to look at finding the midpoint of the line. We know that the equation of this line, we've just said, is y equals 2x plus 3. And we're going to look at the midpoint of a particular section of the line, because this line, although we're only showing a part of it, we know that it actually can extend in either direction for as long as we want it to go. So we're going to find the midpoint of a section. We're going to find the midpoint of the section AB. So what does this mean? Well, it means that we're going to find the middle part, the point which sits exactly halfway between A and B. Just stop the video for a minute and see whether you can decide exactly where that point is going to be. So hopefully you've decided that it's going to be here. And you can work out why, because you can join a triangle around A and B. To get from A to B, you've gone across 2 on your x-axis, So you're going to go across half of that distance, which is across 1. And to get from A to B, you have gone up 4. And you're going to do half of that, which is to go up 2. And you end up at this point here. But what are the coordinates of this point? I'm going to call it M for the midpoint. Now, you know that the coordinates of A are -1, 1. You know that the coordinates of B are 1, 5. So what you're actually doing is you're finding halfway between the x coordinates and halfway between the y coordinates. In order to go across 1, which we've said from the x, you're going to go from -1 across 1, and you're going to go to the point 0 on the x-axis. You're going to go from 1 on the y-axis, you're going to go up 2, and you go up to the point 3. The coordinates of M sit exactly halfway between the coordinates of A and B. So halfway between -1 and 1 is 0. And halfway between 1 and 5, we get the value 3. So the midpoint of the line AB is at 0, 3. And the next thing we're going to find is we're going to find the length of the line AB. And we're going to use Pythagoras' theorem, because if I draw a line across the x coordinates from A to B and up the y coordinates from A to B, you can see that I have created a right-angled triangle. And we're going to use this right-angled triangle to find the length AB. Across the x coordinates, we've gone across 2, and to go up the y-axis, we have gone up 4. And so to find the length of the line AB, we can say that AB is the hypotenuse. So 2 squared plus 4 squared must equal AB squared. 2 squared we know is 4. 4 squared we know is 16. And this is AB squared. 4 plus 16 is 20. And so to get to the value of AB, we're going to square root 20. And just quickly do that on my calculator. And we get 4.4721. And so AB, we can say, is 4.5. And that's giving our answer to 1 decimal place. So now we've got a different graph, and we're going to do exactly the same as we did last time. The first thing I'd like you to do is to find the equation of the line AB, looking for the gradient and looking for the y-intercept. So pause the video and see whether or not you can find the equation of the line. So to find the gradient of the line, we're going to see how many we go across 1 square and how many we go up when we've gone up 1 square. And you can see very clearly that we've gone up 1 on the x-axis and 1 on the y-axis. So that gives us a gradient of 1. And our y-intercept, we can see very clearly here, is at -4. So the equation of our line is y equals x. 1x we wouldn't say, but just x minus 4. Again, our coordinates of any point on that line would follow that rule, and the coordinates at A would follow that rule, and so would the coordinates at B. The coordinates at A, you can see very clearly, are -1, -5. Does that follow our rule? Our rule is that our y coordinate must be our x coordinate, take away 4, and -1 take away 4 is -5, so that follows our rule. The coordinates at B are 5, 1, and our rule is that we take our x coordinate and take away 4, and do we get 1? Yes, we do. So you can see that A and B are sitting on the line y equals x minus 4 because they follow the rule of the line. So now we're going to find the midpoint, and we're going to find the length of the line AB. And I'm going to do exactly what I did last time. I'm going to first of all draw in a right-angled triangle. The sides of the right-angled triangle are given by the differences in our x and our y coordinates. Or we can just count the squares. And you can see that the distance along the bottom is 6 squares. 1, 2, 3, 4, 5, 6. That's the difference between our x coordinates. And the distance going up is the difference between our y coordinates, which is also 6 squares. So again, we're going to try and find our midpoint. Now, if we've gone along 6 squares, we want to halve that distance, and we want to go along just 3 squares. And instead of going up 6 on our y axis, we're going to go up just 3, and it's going to take us to this midpoint here. I'm going to label it M. And you can see that the coordinates of that point there are 2, -2. To find the length of the line, so the length of AB, again we're going to use Pythagoras' theorem. So again, AB is the hypotenuse, so 6 squared plus 6 squared equals AB squared. 6 squared is 36, plus another 36 is 72. And so in order to get the value of AB, we need to square root our 72. And so we get that AB, just do that on my calculator again, is 8.485, and so is 8.5, and that's to 1 decimal place. So you can have a go at this one. I'd like you to pause the video, have a look at the line AB, and do 3 things. Find the equation of the line, to find the midpoint of the line, and to find the length of the line. So there is a big difference between this graph and our previous graph, and that is that this is now sloping downwards, so we have a negative gradient. So every time we go across 1 on our x-axis, we actually go down 3 on our y-axis. And we can choose various different points. We can see that each time we go across 1, we go down 3. So the gradient is -3, the y-intercept is at 7, and the equation of the line is y equals -3x plus 7. So now we're going to find the midpoint and the length of AB by drawing in the triangle, and you can see that the differences in x and y are 5 and 15. So we have found a half of those distances, and it takes us to a midpoint of 1.5, 2.5. And then using Pythagoras' theorem, we have got a length of AB as 15.8 to 1 decimal place.